Hi class, this is section 4.3 Congruent Figures. The learning target for today is that we will be able to identify congruent figures and their corresponding parts. So first let's talk about what a congruent figure is. Congruent figures have the same size and shape. You can move, rotate, or flip one so that it exactly fits onto the other one. So they're not always going to have the same orientation. They have congruent corresponding parts, which means they have congruent matching sides and angles. So we could always match one angle to another angle on the other figure, or match a side to another side on the figure. When you name congruent figures, always list the corresponding vertices, which are angles, in the same order. So let's practice listing congruent corresponding parts of congruent figures. So I tell you that triangle ABC is congruent to triangle XYZ. So whenever I list that two things are congruent, the order in which they are listed tells you the things that are congruent. So this is what I mean. This means that angle A is congruent to angle X because they are both listed first. So, angle A is congruent to angle X. What is angle B going to be congruent to? Well, it's going to be congruent to angle Y. This is also true if you're looking at the pictures below. Notice that if you were to flip this purple triangle over so that AB matches up with XY, you would say that angle X and angle A are the same, and that angle B and angle Y are the same. So you can go off of the notation, or you can look at the picture. So that leaves us with angle C is congruent to angle Z. We also have three congruent sides. Side AB is congruent to side XY. Notice that AB and XY are listed in the same order. Side BC is congruent to side YZ. And side CA is congruent to side ZX. Even looking at the order of the letters, this is true. CA and ZX. CA, ZX. So you can look at the notation or the picture. If the measure of angle A is 68, what's the measure of angle X? Well, since angle A and angle X are congruent, we know that angle X would have to be 68. Alright, I'm now giving you that the quadrilateral math is congruent to the quadrilateral rocks. I want you to pause this and try to list all the congruent angles and congruent sides. I will go through them in just a second. Alright, so angle M is congruent to angle R. Angle A is congruent to angle O. Angle T is congruent to angle K. And angle H is congruent to angle S. So again, you can go off the notation, or if you were to flip this green figure, kind of like turn it over on its side, it would match up with the purple figure, and you can go off of those. Now for sides. Line segment MA is congruent to line segment RO. Segment AT is congruent to segment OK. Segment TH is congruent to segment KS, and segment HM is congruent to segment SR. Now we're going to use congruent figures to solve for a variable. We are going to solve for x in the figures below. The information that they're going to give us is that the figures are congruent and that all convex pentagons have an interior angle sum of 540 degrees. So both of these are convex pentagons. They have 5 sides. That means if you add up all the angles, that it has to equal 540 degrees. Well, on the first figure, I'm missing one angle, and on the second figure, I only have one angle. If we were to take this second figure and flip it over onto the first figure, this missing angle would match up with x. So we know that that's an x right there. Now I can use the fact that the angles have to add up to 540 degrees to set up an equation. So I'm going to add up all 5 angles and set it equal to 540 degrees. This allows me to solve for x. So I combine my like terms and subtract 400 from both sides to get that x is equal to 140. This is a completely different problem. Is the statement QRSTU is congruent to MNOP possible? Explain. So the first figure, how many sides would it have? It would have 5 sides. The second figure would only have 4 sides. Is it possible for a 5-sided figure to be congruent to a 4-sided figure? The answer is no, because remember they have to be the same size and the same shape. So no, because a pentagon and a quadrilateral do not have the same shape. Now we're going to talk about congruent triangles. This whole chapter is focusing on triangles. Triangles are congruent when they have 3 pairs of corresponding sides and 3 pairs of corresponding angles that are both congruent. So we need congruent sides and congruent angles. Are the triangles congruent? Here's our first example. Well, we have 2 congruent angles. We have angle L and angle C are congruent, and angle M and angle A are congruent. So we're missing these 2 angles right here. They are not marked congruent, but do I know that these 2 are congruent? Yes, they are congruent because they are vertical angles. So now I've taken care of my 3 angles that are congruent. We need to see if our 3 sides are congruent. Well, I can see that the sides labeled 3 are congruent, the sides labeled 4 are congruent, and then we have the last pair of sides being marked congruent. So yes, these triangles are congruent because they have 3 angles and 3 sides that are congruent to another triangle. The next one, we have this angle and this angle are congruent, this angle and this angle are congruent. Are these 2 angles congruent? Yes, they are, because they're vertical angles. Then we have sides on one triangle being congruent and sides on another side being congruent. Since it's not showing that corresponding sides are congruent, we cannot say that these triangles are congruent. Given that ABCD is congruent to EFGH, we need to find the value of each variable. So first we're looking for angle X. I know that A matches up with E, so if A is 80, that means that E has to be 80. So X is going to be 80. Now I'm looking for side Y, AB. Well, I can see that AB should match up with EF. So if EF is 8, then AB has to be 8, which means that Y is going to be 8. And then finally we need to find Z, which is EH. I can see that EH matches up with AD. AD is 10, that means that EH has to be 10, so Z is going to be 10. Make sure you're matching up the corresponding sides and angles based off of the notation. Don't just look at these 2 and assume that this would be 8 or that would be 10, or that BC matches up with EF or something like that. Always go off the notation. Here's a new theorem. If 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are blank. So if we have 2 angles of one triangle congruent to 2 angles of another triangle, what can we say about those third angles? Well, these are always going to be congruent no matter what. So the third angles are always congruent. So say that the first angles, let's say that B and Y were 90 and A and X were 50. These would have to be 40, which makes them congruent. So angle C is congruent to angle Z. More practice. Given a triangle triangle TJD is congruent to triangle RCF, list the congruent corresponding parts. So we know that angle T is congruent to angle R, angle J is congruent to angle C, and angle D is congruent to angle F. Now for the sides. TJ is congruent to RC, JD is congruent to CF, and TD is congruent to RF. Given that triangle KLM is congruent to triangle XYZ, find the measure of angle X. So, we know that X corresponds to K. So, right now we can't find the measure of X. So let's see if we can fill in Z, which would help us find what X is. So Z corresponds to M. So I know that Z is going to be 48 degrees. Now I can use my triangle angle sum theorem to find out what X is. I know these have to add up to 180. So I set up an equation adding them to 180, and I get that X is equal to 65. Do not assume just because this angle is labeled 48 that it's going to match up to X. Make sure you're paying attention to the notation. Given the triangles are congruent, find X. So I know that we have two right angles, and if I was to take this triangle and flip it around, I would see that this 30 matches to down here. So that doesn't help me find what X is. But I know if this is 90 degrees and this is 30 degrees, what does this one have to be? 60 degrees. The same thing over here. If this is 30 and this is 90, this one has to be 60. So I'm going to use that to find what the angle is. So you can either set this equal to 60, or you can just do 4x plus 90 plus 30 is equal to 180. Combine like terms and subtract 120 from both sides to get that x is equal to 15. Here on this step, 4x is equal to 60. You could have started here to get x is equal to 15. Some of these problems can be done in two different ways. I want you to try this one on your own. In the diagram, triangle FHJ is congruent to triangle HFG. Find the values of x and y. Your answer is going to be A, that x is equal to 4.5 and y is equal to 2.75. So here are the key concepts that we went over today. We learned the definition of congruent polygons, that the angles and the sides have to match up in order for them to be congruent polygons. And we specifically learned this about triangles because that is what our chapter is about. So the three angles have to be congruent to the three angles of the other triangle, and the three sides have to be congruent to the three sides of the other triangle. Anytime you're matching up the sides and angles, they're called corresponding. And the second theorem we learned about was the third angles theorem, that if two angles of one triangle are congruent to two angles of another triangle, then the third angles of both triangles will be congruent. This is the end of your video. Please don't forget to fill out your WSQ, and I will see you in class.